Hello, my name is Chris Kane of Air Gauging LLC, and today I would like to demonstrate the features of the Stotz MSM column. This is the Stotz MSM column. It is pneumatic and electronic combined. That meaning that you can have up to 4 pneumatic channels at one time. This one's configured with 3, but you can configure it with 1, 2, 3, or 4. And it has an additional 2 LVDT inputs on the back, which I will show you briefly. This column was designed as a compact and low-cost solution, but yet it's very packed with features, including SPC. It is a color touchscreen, so you simply there's programs that are selectable in here. I'm going to stay on program 0 for now, but it is a color touchscreen. It uses these quick connect couplers, and then this piece is mounted against your tool, and they simply connect like this, and then they pop off. Again, if you have a multi-port configuration, all of those ports can be measured simultaneous. Now that could be on a tool, on one tool, such as 3 or 4 measuring levels, so that if you wanted to measure taper or something like that, that could be done this way. Or you could have it more as an auto gauge where you had 4 different devices, individual probes or rings, and you just have each one in one position, and then the gauge would auto select as you picked up a device, and that is the one you were using. It would automatically sense that and go to that particular measurement task. I want to highlight some of the features here on the back side of the column. So you got your on-off switch here. It is auto switching in power, meaning that it's very similar to a laptop. You can use it with 120 volt or 240 volt. All of these things that are on this side are standard. So here's your power input. It does have a 24 volt digital I/O on it, so this could be used in communication with robotic loading or something like that. We do have the RS-232 here for serial communication back out. This WTR is for a Stotz selection box. It does have one Ethernet port. This is TCP/IP, and it does have a USB port. Here's your air input. We run at about 3 bar or 45 psi. Here's the location where, if this particular one had it, would be the 2 inputs for the LVDTs. This one does not have that feature, but if they were on it, that's where they would be. All of these other connections here that are blocked off are additional things. So PB is Profibus, which is a standard for the Siemens controller. And then you could add additional analog or digital devices here. So there are a lot of features in it, but yet it's still a very compact design. So now I would like to take a moment and show you the software features of the Stotz MSM column. Again, it is a color touch screen. On its native platform, it can store up to 18 programs. You'll see across the top here it gives you the date and time, and then up here in the left corner it says P0. That stands for program 0. If I simply hit that, a list of 18 different programs comes up. So switching from measuring one part to another is very quick, especially with these quick disconnect couplers, because you can very rapidly switch from one device to another. But let's just start with this Cat 40 tool holder. So I simply select it, and then down here I say OK. And the program will automatically load up. Now this program is customized the way that I wanted it, so but we can customize it to however the customer wants it. But a very common way is to put your logo at the top. And in this particular case, we are measuring a cat taper, which it uses 3 measuring levels, and the cat taper looks like this. And we place it into a ring, and we get 3 different measurements. So we get a large measurement, a middle, and a bottom measurement. Then we're calculating what the straightness is, and then telling you what the angle deviation is. That angle deviation is used to calculate an AT class. The AT class is for angle tolerance class. Now again, this is I'm not trying to confuse the issue. This is a taper, just trying to show you the abilities of this particular column. So calibration is very simple. There is a calibrate button here. You simply calibrate it. In this particular case, it's only using a mean master. Most cases we do use a min and max, but the way you do it is the same. So it tells you that it's a null or mean or zero master, whatever you want to call it, and it always indicates what it's waiting for. So it's waiting for you to start. So basically, you would put your master into this ring. You would hit the start button. Now it tells you the measurement's running. We would already have the values from the master preloaded in here. There is no offset or gain adjustments. So you'd wait for these numbers to stabilize, which I'm not running any air through it or any tooling, so they're stable immediately, but you'd want to wait maybe 2 seconds or something like that, and then you'd hit stop. When you do that, it automatically has calibrated it. Again, no offset and gain adjustment, and it's now brought you back to the main screen. Again, this line is always indicating, if you're not seeing a live measurement, you can look at that line and go, oh yeah, it's waiting for me to press start. So you'd simply load your tool, or you don't even have to load your tool. You could simply hit start. Now these numbers are very stable right now because I have no air running through it or anything like that. But I could not lock these numbers up and just keep putting the tool in and keep checking parts. Only if I want to lock in the value to save it for SPC would I hit the stop button. We have other ways of triggering the stop too. You don't have to hit the stop button, but in this case you'll see if I hit stop, now again it says waiting for start. Now you see here it says AT class none, but we have a whole range of them in there from AT1 to AT8. Right now, because we have almost no deviation on the angle, there really isn't an AT class. If this number would go negative, it will tell you that it's wrong. If we got it around 40 millionths, it would go AT1, and then it would continue to go up. And again, this is just an example. We can customize this however you want the program to look. I want to spend a minute now to go into the statistical part of it. So if this button down here, it's F5, if I go into that, you'll see that my SPC stuff comes up, my statistics. So it gives me part counters, Pareto, histogram, control chart, values graphical, and values numerical. So whichever one I want, or I can just say part counters, okay. Now it will tell me by feature how many of those tolerances were okay, how many were below the lower tolerance limit, and how many were above the upper tolerance limit. And then it gives you a percentage of that as well. Then I can simply say next display. This will take me to a Pareto chart. Now because I was actually measuring without any parts, I don't have any bad parts that will actually show anything here in the Pareto. So I'm going to go to the next display. Now again, I wasn't really measuring. I just was hitting start stop. So you'll see that 14 parts were all like right in the middle of the tolerance, but you can kind of see a little bit here that here's your lower tolerance limit and your upper tolerance limit. You would start to build your typical bell-shaped curve, hopefully, in this histogram. And again, this is by large, in the large diameter. If I wanted to go through each one, then I hit this down button. Now see I'm on the middle. And now you see a little bit of separation. And if I went down again, I didn't hit it, to bottom, you see a little bit of separation. You start to see what it would do. So then I'm going to go to the next display. This is your control chart. You can go into each one of those is like a it says no, it's sample number 3. I think they're 5-piece samples. So I could go back to a sample and say I want the single values of that sample. Yes, and it is 5. So it shows me what the individual measurements were for it. I'm going to go to the next display. This gives me a graphical display of it, so you could see if you were trending down or trending up, again, on each individual feature. So I'm on bottom. If I wanted to go up, I could say now I'm on the middle, now I'm on large. So each feature that is there. And then the final screen here is the actual numeric values with a time and date stamp on it. And if there was a value here that was outside of the tolerance limits, it would be highlighted in red. So that basically shows you what the SPC does, or what data is available to you. So I'm just simply going to go and hit this F3 button. It'll take me back to the program. Now I can also export that data out if I don't want that SPC data resides, or the graphs and all that only reside inside of the column. If you wanted to export that data, that is very simple as well. I now want to show you how to export the data if you wanted to get it out of the device and into your own SPC program. If you have a USB stick, you have to have a USB stick on it before you do it, otherwise you'll get an error. But you simply come up here to the middle and hit enter here, and there's an option right here, data export. And as soon as you do that, it gives you several different options here. I can choose text, XL, which is, and then they got a period, which means period delimited, or XL comma delimited, or DFQ, which is a Stotz format. And then the user is set up for something in the future. Then it tells you the export file name. If you do need to change that, that will, it's mounted to the USB on the back, and it's going to just save it as P1 and then whatever format you chose. But you can rename it if you want. You simply double tap on it, a keyboard comes up. You know, this is your backspace. Whatever you change it to, then just say OK, and you get the options. It tells you there's 14 measurements in there, and you can say all values, or if you say last values, then it says how many of the last values. So if you're doing a capability study and you've measured 50 times and you want the last 50 measurements, you don't have to write all that down. You can just export it here. Or you can say from and to, from what measurement to what measurement. Or you can say from this date to this date, and then you can simply export it. I'm going to say all values. I'm going to say export. And then it tells me that it has saved it. And I say OK. One other really nice feature of this is if I click up here in the upper right hand corner, you will see that it will print this screen. And again, it tells you the file name it's going to give it. It gives it a PNG file. And you have to have the USB in, and then you say print to file. Now, you got to give it a little bit of time, but if you remove that USB now, you would actually see a PNG file of this exact screen capture. So it's a really nice thing to show colleagues or pass on to a customer. All these features I'm talking about with the USB could also be done if you connected it to the Ethernet. One other thing about the programming I wanted to show you, but I couldn't do it on this single calibration. I'm gonna come up here and select a different program. This particular one, we did it for a customer. So yeah, we've got their logo up there. This is for an HSK. But what I wanted to show you is that this taper chart here actually, I'm going to go ahead and stop. I'm going to go calibrate. This is a 2-point calibration. So these numbers are pretty wild because, again, I'm not measuring anything. Okay, good example. We can actually turn on calibration plausibility. So if your calibration deviates too far from the last time you calibrated it, and those limits can be set, it will say, Current calibration will not be used, and wrong mastering. That was totally unplanned, but it's actually a very good lesson of something I didn't mention, but that you can set those. So what that does is it saves you from possibly calibrating backwards. So now, having done that, I'm going to have probably the same problem here, which I do because that was on the max. So what I'm going to do is I'm actually going to go to another program that I have not calibrated so that I can show you what I mean. So I'm going to calibrate. It's asking for min, start, stop. Now it's asking for max, start, stop, and then I just want to hit start. What I wanted to show you is that taper chart there is actually, of course, this is very exaggerated. Again, we're not actually measuring anything. If you're measuring, it's very repeatable. But I wanted to show you that that can actually show you in an exaggerated form what your taper looks like. So there's lots of options of what we can show you. This is just a general video to show you what some of the possibilities are, and if you have interest in that you would contact us and we could talk further. Another feature I had not talked about, but I think it's a good one. We can actually, I'm going to stop it so it settles down, but we can actually show you the degrees, minutes, seconds of an angle as well. And I didn't touch on this, but you see the red numbers and the green number. Basically, if it's out of tolerance, any feature that you want to be checked, it will go red. If it's out of tolerance, we could also set it to go yellow if it was in warning limits, or we can change the colors however you want it. And then here, it's a good example because the angle actually was right. So you can see the form is right, it's just not the right size. So our angle is right, but the two diameters are not right. So therefore, this part would not be good, but it's a good example of things that you can do. So again, this display was customized for this particular customer, and we would offer that same thing to you. So in closing, I wanted to say that I think that, or I hope that you have the opinion that this column is really packed with a lot of very nice features, and that it would definitely meet the requirements that you have. And the other thing I would like to say is that it's actually very affordable, surprisingly affordable for all of the features that you're getting. So give us a call or send us an email. We'll be glad to work some numbers out for you. Thanks.